This is part 5 of our Triplanar rock tutorial, and in this one we're going to add detail normal maps and a way to clean up some of these rougher looking edges here. So what we're going to do is show you where I'm at with the material. I have a snow texture for my top, and I'm using a basalt diffuse texture. And I also imported the normal maps that go with it. Then I input them into the top blend node that we had made last time. It's basically the same node, and it interpolates between the two just fine. But we want to be able to add detail normal maps to this. And to do that, we are going to have to change our triplanar projector node. Now this is going to look a little ugly when we're done, but it should work just fine. We're going to need to make a little space. We're going to have to move all this down here. Now we need to duplicate, basically coming off our world position node, we need to duplicate the divide node and all these masking nodes. Control W, bring them down here. And we're going to have to, let's go ahead and duplicate this too, so we don't have to copy everything. We're going to call this one detail normal map scale, and make sure that this world position output is hooked up to the divide node. Now we also need a second texture to work with. We're going to input our detail normal texture. So Control W, name it detail normal map, and use preview node. We're also going to need one more input, and it's going to be a Boolean. We're going to name it use detail normal map. Use the preview value, and we're going to give this a default value of false. Now I have to set this up to take a Boolean as an input. And we will default to false because we want to use this for both regular 3-color maps and for normal maps. Move all this out of the way. This is going to get very messy really quick, but we'll try to make sense of it. Okay, we're going to need 3 switch nodes. And for the value being false, which is our default, it is going to behave exactly as before. So we're going to connect all of our texture samples to false and the output to the multiply node. Remember, everything with these nodes is masked off the same as before. It's just that we're going to end up combining normal maps before they're blended in according to the direction of the vertex normal. this out of the way. Now we need a texture sample for the normal map from each direction. So we need to copy all these texture samples. And the UVs are connected exactly the same way as the other ones are, except we're using the ones that are divided by the detail normal parameter. And hook up our texture map. Let's try and get these, clean these up just a little bit. Now we need to combine these two normal maps. There's two different ways to do this. You can either basically multiply the blue channel on one of these maps, preferably the detail normal, by 0, and then add the red and green channels together. It's pretty much the cheapest way to do it, but a more accurate way to do it is to use the blend corrected normals node. Or blend angle corrected normals, I'm sorry. And this one is a little bit more expensive, but I don't think in this particular instance we're really worried about cost all that much. So connect all these and then connect it to the true value on our switch node, so that when blend angle corrected normals is set to true, it will use all of these inputs. And that is pretty messy. Let's go ahead and save it. Okay. Now in our top blend function, use detail normal map is exposed, and the detail normal map texture 2D is also exposed. So what we'll have to do is we'll have to input, here's the side texture, or I'm sorry, the top texture and the side texture. We're going to have to duplicate that. Call this one detail top, if I could spell that right. We'll drag that one in. And this one will be detail sides. And also connect it to our texture object. Now we need a Boolean input to be able to tell these functions that we want to use the detail nodes. So I have to create an input. Boolean, use preview node. And this one is going to default to false. Save it, and we have all of our inputs. we do need to clean these up so that they are in order. Let me go ahead and start with the top blend. 0. It should be 1, 2, okay, so everything's a little easier to see. A static bool. I don't know. Make it a static bool parameter. Use detail normal map. Default value is going to be true. Go ahead and hook this guy up here. Put it right there. Here's our detail normal map for our top. And our detail normal map for our sides. Now we also need a detail scale, don't we? We forgot to put that one in there. We'll put detail scale, put it on top blends. Move all this up. Should be a scalar. And of course you can split this up into two if you want more control over the detail map scale size. And let's set the default to, like, I don't know, 80. Something so it makes it very obvious that we're using it. Let's preview, save it. Okay, so let's see what it looks like in the world. There we go. We have detail normal maps applied. Alright, now we want to clean up a little bit of the shading. It's not quite perfectly blended in a lot of these spaces. And since this is an automatic process, it's not always going to give you what you want. So if you want to clean this up, it's actually fairly easy. What we have to do is we have to go into our blend coordinates node, our function. And what we're going to do is we're going to set this up so that it blends not only based on direction, but also based on vertex color. Let's go ahead and move this stuff out of the way. Now we're going to add a vertex color node. And I like to add on the red channel and subtract on the green. It's just kind of my personal preference. You can do it however you want. So put an add node. And basically this is adding to the mask, or to the blend mask. Include a subtract node. Put this up to green. And we're going to clamp it. We don't want any weird values going above 0 or 1. And this goes to our up mask output. And we need to add, basically duplicate all this. Red goes to here, green goes to the subtract node. Now we're going to take our blue node from our breakout components down here. Add it in, and multiply the output of all this to where the blue node was going before. Sorry, I did make a mistake. the output of this clamp node needs to be multiplied by the output of this clamp node. Save everything, save it again here. Fill the paint color with black. And now it fills everything. We can paint the entire thing. Fill in whatever areas were basically missed. And it doesn't have to be perfectly red either. You can drop it down a little bit, a little more subtle effect. Let's drop down a little more. It's still pretty intense. Now, if there's areas like down here where we don't want all this white, just paint it green. And it takes it all away. And since the subtraction is done after the addition, the red will basically overwrite the green. Sorry, the green will overwrite the red. Now, let's go ahead and fill this back with black to get back to our default look. Now, right now it doesn't look very convincing, even for something that's done fairly quickly. So what we want to do is we want to add some height to this snow. We want to give it some thickness. Since we're aimed at high power machines, let's go ahead and add some tessellation, which will really give us the proper vertex density we need to make it look somewhat realistic. First thing we're going to do is add a tessellation multiplier parameter. We'll start it off at, let's say 3. Convert that to a parameter. We're going to convert that to a parameter, and to actually use the tessellation, we have to go down here into the material properties. And where is it? Down under tessellation, you want to use flat tessellation should work fine. We do, however, want crack-free tessellation. Now that a rock is tessellated, we have to tell it how far to push out the vertices to give it some shape. And we only want it to displace where the snow is. We don't want it to displace where the rock is. So what we're going to do is we're going to add another one of these nodes. I'm actually going to copy the diffuse section since I'm going to be reusing the snow texture as a displacement texture. And for the sides, I'm just going to add a black texture. Let me get rid of this. How to get my tessellation node stuck in there. Remove this tessellation node out of the way. And we can actually put it back here where it won't get in our way anymore. Now I've made my own black texture because you can't just import a color into this. There it is. It's just a simple 4x4 black texture. Now we also need to connect our material parameters. Let's see, our blend sharpness, because we want all these to match. Blend sharpness will go here, and texture scale will go here. Now we need another parameter for displacement distance. And we're going to multiply that by the result of our texture interpolation. It really bothers me having crossing lines here. Now we also have to multiply that by our vertex normal in world space. Basically, this will give us the distance to move, and this gives us the direction. Now we put this in the world displacement spot. Save it and let it compile. Now that that's finished compiling, we should notice that our snow has some depth to it. We could take and paint some more red on there, and you can see how it pushes the vertices out. It kind of covers everything with snow. Alright, now another problem that we're going to have is our two materials may have dissimilar roughness values. But as you can see, this is already getting to be very expensive. I mean, we're at 229 instructions already. So instead of doing another top blend node, we can just do a lerp, a linear interpolation between two textures for our roughness values. We'll base this lerp on the output of our snow displacement section. Now I have a roughness map that I made for my snow, but you can just use a numeric value as well. And we're just going to use the diffuse from the basalt. And we also want to have a roughness multiplier. Convert that to a parameter. There's the effect of the roughness map. Now at this point the snow is looking a little bland, so we're going to add a Fresnel node to kind of make it look a little more interesting. Now we'll also need a color. We'll convert that to a parameter. Fresnel color. I'm going to go with a blue. Yeah, let's pick one out of this normal map here. Because, you know, why not? And we need another scalar parameter. Called Fresnel. Color strength. Multiply the color by the strength. Add the color. Add the result to the output of the Fresnel node. And we're going to multiply it by the output of our snow displacement node from earlier, same way that we did the roughness masking. Now this gets connected to a subsurface color pin. And to activate that, we have to go into our material expression and change our lighting model to subsurface. Right now it's being multiplied by 0, so we're seeing no effect from this. That's a little better. Let's see what this looks like in practice. You see that adds a lot of blue to it. You're going to want to clean it up with the vertex painting. Now, to make this a lot more efficient to work with, we're going to make a material instance for this material, and we're going to apply that to our rock. So this way, if we want to make changes to our material instance, it doesn't have to recompile every time. But that's pretty much the bulk of it. Now we can basically drag out a bunch of rocks. Scale and rotate them in weird places. And make a very, very quick pile of snow-covered rocks.